we're going to learn how to use our periodic table in order to figure out the charges of elements. So far you know how to use it for placement of metals and nonmetals. You know how to do electron configurations, and then you know how to do valence electrons, right? Group 1 always has 1 valence electron. Group 2 always has 2 valence electrons. We don't worry about the D block. 13 is 3 valence electrons, for example. 17 is 7 valence electrons. And those valence electrons help us figure out our dot diagrams. So you can see I've colored in a few elements. So I'm going to do the dot diagrams for those elements. If you can pause the video and do the dot diagrams for the highlighted elements, then you can check your work in a minute when you're done. So check your dot diagrams with mine. This is nothing new. You should kind of have this down. Now we're going to think back to when we were doing our diagrams for our ionic compounds. If something only has 1 valence electron, it can either lose that 1 or it can gain 7. Okay, so you would have picked lose 1, right? That's the easier thing to do. So it's going to lose its 1 valence electron, and it's going to become a positively charged ion with just a +1 charge. Okay, strontium has 2 valence electrons, so it can either lose 2 or gain 6. It's going to lose 2, so it's going to become strontium, not just +1, but a +2 charge. Okay, and then aluminum has 3. It's going to be easier to lose 3 than to gain 5, so aluminum's charge will be Al +3. Okay, so you'll notice that your metal ions are going to be positively charged. Your metals are going to turn into cations. Now if we go over to the yellow ones, the nonmetals, nitrogen can either gain 3 or lose 5. So it's easier to gain 3 electrons. If nitrogen gains 3 electrons, it's going to become N with a 3 minus. And remember, the whole point is to get to that octet. Selenium is going to become Se with a 2 minus because it's going to gain 2 electrons to get to the octet. And when iodine has a filled octet, we need to gain, or to get it to a filled octet, we need to gain 1 more valence electron. So it's going to have a -1 charge. Notice that argon already has 8 valence electrons, so it will not have a charge. Okay, there's no reason for argon to gain or lose electrons. It's already very stable with 8. Okay, so let's put the charges on our periodic table. You'll notice that potassium is in group 1. Sodium is also in group 1. Lithium is also in group 1. Guess what? They all have 1 valence electron. It's going to be easier to lose 1 than gain 7. So anything in group 1 is going to end up with a +1 charge. Okay, similarly, anything in group 2 with the 2 valence electrons is going to lose those 2 to have a +2 charge. We're not going to worry about our D block. Okay, we're just going to make a note that those charges can vary, and we'll talk about that next time. Then when we get over to aluminum and below, be careful. These are the only metals. Boron's actually considered a nonmetal. So for aluminum and below, these are going to have 3 valence electrons, so they're going to have a +3 charge. Okay? Now, there's kind of a dividing point, and that dividing point is going to be group 14. All right, notice I didn't highlight any from group 14 because they have 4 valence electrons. So you're like, are they going to lose 4 or gain 4? They're not going to do either. Those things are not going to bond ionically. All right, so let's go to nitrogen. Nitrogen, we said up here, has a -3 charge. Selenium has a -2. Iodine has a -1, so you can kind of see the pattern, and argon has no charge. So I usually start actually from the right and say, okay, my noble gases are not going to have a charge. It's going to be 0. And then I just kind of count backwards. My halogens, they're going to be a -1. Why? Because they have 7 valence electrons. So they're going to gain 1 to complete the octet. Oxygen's group, or group 16, is going to have a -2 charge. And the nitrogen's group is going to have a -3 charge. Okay, if you look on your blue periodic tables, you should in fact see the charges there. But it's always good to kind of know the pattern. So I'll just do one more slide because I know you don't have a periodic table that you can write on. So I'm just going to do a sketch, and you're going to laugh at me because it's not going to be great. But I am just going to do a sketch of the periodic table. Okay, I'm not going to worry about the F block. We don't need to worry about the F block. Okay, so this is my S block, this is my P block, up here's helium, here's hydrogen, this is my D block. It's not beautiful, but it will suffice. So in pink, I will put my valence electrons, okay, just for my S and my P block. So group 1 has 1 valence electron, group 2 has 2, group 13 is 3, 14 is 4, 5, 6, 7, and 8, although helium only has 2, right? And then in this blue color, I will just summarize again the charges, the common charges. So in group 1, it's going to be a +1. Group 2, it's going to be a +2. Group 13, it's going to be a +3, but then remember it kind of changes. So now I'm going to start from the noble gases. It's going to be a 0. These guys are going to gain electrons to complete their octet, so -1, -2, -3, and we're going to leave group 14's blank because they don't usually take on charges.